Okay, so here we go. This is our recording for Design 301. It's lecture guided practice. It's June 23rd. We're on our Google Meet, and we're going to talk about mechanical and architectural dimensions. We're going to just let you know about civil. We're not going to work in civil too much until a little bit next week. And then in title blocks, we'll talk about drawing sheet sizes and we'll go over some size and information about them. And that's where we'll talk about model space and layout and things like that. So here we go. Let's go ahead and jump right into it. I've got a little demo here that we can work on. And this is a mechanical drawing. If you look at the model, I did it from a solid model just because I'm lazy and it's easier for me. And I've made some what are called views or viewports. If you look at it, this is very typical of some sort of a driver that would go, a drive adapter. This would go into a hole somewhere. There would be a key that would transmit the torque to the outer part. And then sometimes there's a flat on it that you can run a set screw in just to help keep it in place. So this would be, say, a gear or a driver, and then something would slip onto here. So this is a real common little gewgaw. And when we look at it from its main front view, we can see kind of the shape, but not really. If that's all you saw, you wouldn't really get much information. You'd have to come up here and go, oh, it's round, and it's round, and then there's some weird little thing back here, and then there's this weird thing on the side. And because I wouldn't be able to dimension this off of these things, I cut it over here so I can get a dimension. And this is a view of it. So let's talk about how the dimensions would look. And this is called just a section plane or a section line. And I don't really need this AA thing to show up. And there's all sorts of stuff you can do with this thing. You can edit it, you can flip the direction, you can do all sorts of stuff on the properties, but we'll leave it there anyway. Normally, the view that it refers to would have a list on it down here that would say, this is section AA. But there's a rule in orthographics that says, if it's just an orthographic projection, you don't have to label it. So there we go. All right. So now I want to dimension this thing. And so I've got some dimension styles set up that I can look at. I can have fractional dimensions and 2 decimal places. Here's 3 decimal places that are plus or minus 1/1000th of an inch. And so I've set all these up. And depending on the engineering intent, these will have some meaning when I put them on. And so I'm just going to go ahead and do that. I can pick, and we're going to go over this a lot next week. I'm just trying to do some stuff. And I'm just going to show standard dimensions. So there's a standard dimension. There's another standard dimension, and I tend to try to get things to line up nicely if I can. And then there'll be 2 dimensions here, and believe it or not, the way you dimension, and you don't have to know this either, I'm just saying it, is you always dimension to something that somebody can measure. So we want to be able to dimension that to something somebody can measure. And you could put a tool from the outside edge of this to the inside edge. That's measurable. And so then we've got this up here. And so that's a typical way. And usually there's something that says that there's a center line also, but I'm not going to go too whole hog on this. But then this flat would also have something. And this quadrant O snap is super useful. So now I've got a bunch of dimensions on there. And if we see here, it's kind of sloppy. I try not to have things crossing each other. So I'm going to move that up, hopefully to somewhere. Get rid of this really quick here. To somewhere where things don't cross there. So that's a nice clean little view. And then over here, the only thing I need to do, I've got all those diameters, so I'll measure from the end down to this point. Actually, I'm not even going to bother that. I'll do it over in the other one. I'll just do sort of an overall height here. And I like, in general, if my engineering intent allows, to provide an overall. Now, it could be that the most important thing is the length of this line, but I'm leaving it like this for now. And then I've got a little bit more to do over here to finish my dimensions. That dimension needs to be known. And I think that does it. All these things are done now. Now, engineering intent in mechanical has stuff called dim styles. And I'm going to do this two ways now. First, I'm going to show you with the properties. Okay, so I want the things that are pretty important to be 3 decimal places, and the things that are not so important to be 2 decimal places. So I can do that. If I look at my properties, let me get my properties box up. You'll see over here that when I click on it, there's all sorts of stuff in here that I can talk about. And way down here at the bottom, there's the primary units, and it's decimal. There's the precision. So I can change that. And it's sort of like changing the layer. And not only that, I can change a bunch of them all at the same time. So I can change all of those to a precision of 2. And that's not too bad if that's how you want to go about doing it. And then I think some other ones are a little bit more important. Basically, actually, this diameter would be important. This one would be important. And I'll be right there with you. Let's see, we've got, go ahead and pipe in, Stephen, if you want to just ask a question. Well, the standard is if you're able to see the full diameter in mechanical, you try to use the diameter mark, because it's like that's what you're going to measure. It would be really hard to put a measurement tool from this point here to this point here, because I don't know where that point is. But it's easy to put a tool from this point here to this point here. That's called a caliper. And so I want to, where I can, measure show a measurement that can be made. Does that make sense? Yes, yes. Or actually, since the machinist is now a machine tool, they really don't care. You're doing it for the inspector. But it's definitely for a person who can touch this thing and grab it in a certain way to get the information. Okay? And so that's why that would be done, if at all possible. So let's see, what would be some other ones now? This one would be 3 decimal places, as would be, as would be that one. So I can come down here and where's my precision? I'll make those ones. And so these things all mean something. This one can also be 2. But you can see, I mean, I'm clicking around and doing a lot. And that's okay. I can do that. It's not too bad. There's another way I can do it though. So I had to go click, 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 and touch all of these and look at all these things that I might be having to change, right? There are so many things, arrow sizes. Like, for instance, all of these are actually written a little bit too big for most mechanical standards. Mostly we make our text 0.12 high. And I can do that. And mostly our arrows are 0.12. And that's just, a common standard. So now it's starting to look right. But see how I have to click, 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 and then, find this thing and find this thing, and my dim lines, my offsets, and there's all sorts of, my text styles. There's lots and lots to do and figure out here. And then I still have an issue with this one, because usually, and we're not putting it on here right now, we would have a note or something that says, if this is listed at 2 decimal places, I have a larger tolerance. I can accept more variability in how the machinist makes this part than if it's got 3. And sometimes I need even more. So then we use these things called dim styles, and I go, I really want that one to be well controlled. And so I can set a dim style that has tons of information in it. Okay? And so most people, once they've figured out what these things are, you can change them all by the properties. But then there are also things called dim styles that you can make. And next week, we're really going to go into making a few dim styles and making fully dimensioned drawings that do meet some standards. I'll talk to you a little bit more about the standards. One of the things that I don't like too much about the layering standards that they use here is I don't think that they make the geometry lines heavy enough in the AutoCAD standard. And I might have to go back and fix that one and try to find it. And I think it's this MD visible. Let's see what they made MD visible. It made that. It made it 0.02. And I'm used to saying, oh, well, it would help if I had my line weights on. There we go. So 0.02 is okay. I usually use a 0.028. But that's not too bad either. I forgot to have my line weights showing. So now you can see I'm getting sort of a standard drawing. I've got my orthographic views. I have some dimensions. The next part of the standard is to have a title block. And title blocks tell you about the drawing. And I'm just going to put down a very simple title block. And next week, we're going to go into a little bit more complicated one. And you're going to have a chance, and I'll show it tomorrow, how to make your own title block. And that's sometimes done. Usually a company has them for you. And so here we go. I've got this. The next thing I need is a title block. And so how do I get that? And by the way, notice I'm doing this all on my piece of paper, And do you see something wrong with these dimensions? They're not on an appropriate layer. What layer should the dimensions be on? The dimension layer. Okay, and so that's one more thing. Oops, sorry about that. And so there we go. All right. So it's coming along. Now I need something called a title block. I'm going to show you how most places do it. They have something called the Design Center, and you can open up drawings. And here I've got, I think I have my title block. I'll just look in here for blocks. No, they're not in that one. There we go. And I've got all these title blocks in here. And I can just grab one and bring one in. So I'm going to do, I think I'm going to do this one. Watch how cool this is. This is a drawing, essentially, that's already been made. And I think, yeah, I think that one will work. Layout. And now I'm looking at all these. I think this one works. Look at that. Is that the coolest thing? And all this stuff. This is page 1 of 1. I have a scale. 1 equals 2. I can put all this stuff in here automatically. And isn't that cool? It'll all show up. And then I just have to move it where it goes. And different pieces of paper come out differently. This outside thing isn't going to line up and show up. So I can actually move that. It fits right on it. There it goes. And depending on your printer, this is my printer margin. So it should show up okay. I can even move it a little more. So that's how I get a full one. And if I want to edit that, it's ATT edit. Click, and all this comes up. So when I save it, this is called Mech Demo. And I can give it the same Mech Demo, and it's drawn by R. Schuster, and it's 06/23/21. And then when I go like this, everything changes. Is that the coolest thing that you've ever seen? So you're going to get a chance to make one of these. Not quite so fancy. You won't be able to make it autofill. We do that in Design 302. But you'll be able to make one of these of your own that you can work around with. So now I've got kind of a cool drawing. So that's mechanical dimensions. Now let's talk about some things. You'll notice that right here, 2 of these dimensions kind of cross. The standard is not to have those cross. So over here, there should be a annotation break command. Let me get into annotate. Here's break a dimension. So I can break this one and that one. Is that kind of cool? And that's commonly done. And that's called annotation break. The other thing that you'll see is wherever possible, there's a little gap here. I'm using arrows. All of my dimensions are in line. And in a mechanical drawing, you read it from the bottom of the page looking up. Okay, so those are some of the mechanical dimensions standards. And the other big standard is we always put our dimensions on what are called visible lines. So I could not dimension it to this hidden line. And that just happened back in the 1970s. And I don't know why, because I was just like not even in the industry yet. It was already powerful in the industry. I don't know why that happened. That's just the way it is. Well, that means it's my section AA. But I don't need to label AA over here because it's obvious. Okay. And unfortunately, AutoCAD doesn't let me get rid of that without getting rid of the whole thing. It really doesn't even need this. And so sometimes people will put that onto like a layer that's white or something like that that doesn't exist, or they'll put it onto a different line type. Inventor gives you a little more control over this. AutoCAD does not. But that just means I'm looking at this part, cut through the center, and I go the opposite direction of the arrows and stand over there. So I stand over here looking at the direction of the arrows, and it's cut in half. And these lines mean that's where there's actual material. So this little cutout up here is this little thing right here. And the AA is just the keeping them ordered. I mean, I've worked on drawings that have 8 or 9 of those, and it gets pretty hairy. So those are some of the standards that go with mechanical. So you'll see, like this one, they're in line with these are the extension lines. This is the dimension line. And so it's always kind of in line with it. Now, the only time it's not is when it won't fit. And I could probably get that to fit inside of there. And that would be a cleaner way of looking at it. So you have a little bit of choice of moving it around. This one I probably can't get to move inside. Let's see if it will or not. No, it just won't set in there. So I've got to bring it out one side or the other. All the other ones look pretty clean. There are a few other standards that you'll really get into later on. Now there's one other standard. See how these are kind of lined up? This lines up with this. I'd like to get things lined up as much as I can. So one of those two needs to move a little bit. And if I can, I'll get this to move in, and I'll try to get this to also line up. Those are just some mechanical dimensioning industry standards. And there are so many, it'll take you our whole program to learn them. Okay, let's take a look now at architectural dimensioning. And here's a model. And you can see this is 24 feet. I can put some other ones on here, but I want to show you one of the differences. Notice on mechanical, I never dimensioned anything more than one time. You do not see another dimension from here to here, saying that 3 plus 1 equals 4. You don't see that. That's called double dimensioning, and we talked about that a little bit with the tolerancing. Architectural dimensions do have that. You can see 18 plus 6 is 24. 9 plus 9 is 18. That's just typical of architectural dimensioning. You'll also see a couple of other differences. Architects use what's called a tick mark. They also put the dimension above the dimension line so that it's not broken. They also let you work from reading from the right side looking left, or from the bottom looking up. So these ones are to make them line up with the dimension line from the right side looking left. So if I were to do one over here, I've got the wrong dim style. And we'll talk about that in a minute. You see, right side, and they would put this over here. It's obvious this wall goes all the way across. Architects would put this over here. And so that's good. Now, I didn't do this to the greatest extent. All of this gap and this gap and this gap should all be even. I don't quite have them even, but I'm close. And it's the same way on the mechanical. Oh, I spent hours and hours and hours laying out the dimensions before I even put one on when I was a hand drafter. Okay, so then there would be another dimension from here to here. And then there would be a dimension across the whole thing over here. So that's just how architectural dimensions go. Now notice here, I am dimensioning in the model. And although this is 9 feet, I have to play with my text to get it big enough. And so if I look at my properties, my text is listed at 1/16 of an inch, and it really should be 1/8. Should be 1/8 tall. But that's also, just think, if I make something that's 1/8 of an inch tall, I'm going to draw a line now that's 1/8 of an inch tall. That's how big my dimension would print out if I didn't do something. I kind of have to know how big is this going to be on my piece of paper. Okay, so on my piece of paper, this is huge. This is 24 feet. I have to shrink this down a ton to get it to fit on my piece of paper. As a matter of fact, I have to shrink it down by a factor of 64 to get it to fit. So that means I need these things to print out 64 times as big for it to come out on my piece of paper at 1/8. I know that's kind of weird. Okay. So this is how big 1/8 is. So obviously, if I shrink this down 64 times, it's going to be the size of that little square. I would never see it when I put it on my piece of paper. Okay, so I'm going to go to, it's going to be, that's 3/16. There we go. See, you can't see that tiny little dot there, but you can see this because it's really quite big. It's really quite big. So how did I do that? When I click on this and look at my properties, I say, okay, I want my text to be 1/8 when it's on the piece of paper. So I'm going to have to use that scale factor that I'm going to use. So when you do architectural drawings, you're always thinking, what's it going to look like on the piece of paper? What's it going to look like on the piece of paper? And if I put my dimensions in the model, I got to think, when I put this on a piece of paper, that dimension is going to shrink by a certain amount. And how much is that going to be? And you type it in over here. Okay. Your text height is a standard. Okay. That's going to be your standard, whatever your company uses. Now in mechanical, 1/8 of an inch is just like That's what everybody uses. In architectural, some people use 3/32, some people use an eighth, some people use 3/16. Sometimes they change it depending on the paper size. So this is not nearly as quite as locked in as mechanical. Okay? But that's how you do it. Now, that is a very common way that people do things. They put a title block or a box around it here, and then they go put it on the piece of paper, and they make what's called a viewport of just that part of the drawing. And they have little views all over the place. Now, another way to do that is like this. Okay, I'm going to show you. These are all on my piece of paper, and in my model, I had a view that's clean. It's clean. And now, this one, my view is of the model. This is another view without the stuff. So now, these are going to go on directly. When I put my annotations on, I want them just normal size. Except I think those are 1/16 of an inch. Hold on a sec. I have to fix that up a little bit. Somehow I've got one that's got the text as 3/32 and I want it 1/8. There we go. Okay, so that's two different ways that you can go about doing it. And architects do that all the time. Yep. That's part of it. The other part is different people, framers measure from one part of the wall, other people from another part of a wall. So they're just making sure that everybody has some place to measure from that they can get to and they can look at and they can see. Now, I'm not really an architect, and so I listen to our architectural professors all the time. Another thing is like, this is really obvious, but another thing that happens are design changes all the time. And so this is a way also that keeps, if somebody made a change on this room and things don't add up, then it's real obvious all of a sudden. And so that's another thing. That was sort of left over from before CAD, right? Now everything, like, if I were to stretch this room and change it, this dimension would stretch with it, which is really cool. So there we go. So the things to note, though, that are important are there's always a little gap. In other words, if I put this down to here, it's the same way. Let me see if I can get this to come. I'm going to get rid of those two for a sec. If I were to do the dimension from this point to here, see how that gap is no longer right there? That's just sloppy drawing. It's sort of like, it doesn't make the drawing clear. We always have these little gaps right there. That's a really important thing. We use tick marks. They can go sideways. The important thing is that you can either change them in the properties if you need to, or you can set these things called dim styles. And we're going to really talk about dim styles next week and how to make them. But you'll see I have a template that's all full of those. If I look at my dim style, look at all the dim styles that I can just pull from, and you literally just drag it into your drawing. I can do the same thing with layers and stuff like that. Okay. So that's what I wanted really to go over and show you about these things. Now, this is, let's put a title block onto this one too. So my blocks are in here. I'll do an architectural B-size block. And you'll see a lot of it looks the same. I'm not going to worry. Oh, that wasn't supposed to be a B size. That was supposed to be an A size. Okay, and I'm going to do this two ways now. So let me put in A size border. There we go. And this is that thing that's bothering you, right? Like, well, what's going on with that thing? You know, first of all, it's not in the right place. I have to move this a little bit. And then it's kind of like, well, what's going on? It's sort of in the way. And so I can move it so that it overlaps my view. So that's one thing you can do. But the other thing is if you pick it, you can put it on a layer that won't print. And that's called the depth points layer. So you can now see it and reframe things and move things along. But when you look at your layers, see how on depth points the little plot icon is like really light? That means it won't print. So now if I do a print preview, and I'll just print to a PDF or something really easy. You see how it's gone. And I think that's what you're mostly going to be thinking about, right? Did that actually answer the question that you had? Okay. Yeah. So that was your viewport, which again we'll talk about more later on. But there we go. Okay. So those are some industry standards that we can play with. Most drawings have title blocks, and we're going to talk about making title blocks more. But look, that works out pretty well here too. I can put one on here. But there are many architectural companies that just want their title block put around this thing. Oh my gosh, how am I going to get that tiny little title block around there? Watch. I'm gonna say I want it to be an A size. Let me just put it in here again. Let's see. There it is. Well, it's too small. I mean, because it's meant to just be on a piece of paper. So now I have to do something called scale. And I have to know that it's going to be 64 times as big. And now all of a sudden it's kind of right. So that's commonly done. Looks like it needed to be even more than that to actually fit with these dimensions that I put in over here. I'd have to scale this even more. Okay, which is what I love about working on layouts. I can so quickly and easily rescale this if I get more dimensions to put on here. And they just snap right to it. It's so nice. But we'll talk. I don't want to overdo it. But I did want to say that many architects do work this way. They work all in model space, and this just becomes a page. And they have their model full of page after page after page after page. And if they need another copy of this view, they copy it. Which is kind of like, that can be hard. So they've made things called references, but so it can be done. But most will just make a copy and put it onto a view and use that view over and over again and just leave the dimensions that they want in one thing. Okay? So there we go. That's really what I've got to talk about. Let me make sure I've done everything I wanted to talk about. Oh, now we need to talk about drawing sizes, sheets, and information. So that's what I wanted to talk about on dimensions. Just some of the standards for mechanical and architectural. I have put on here 2 videos if you're interested in making a dim style. We're going to do it next week, and those will show up next week again. So these are just like extra if you want to. So now let's take a look at this, drawing sizes. Mostly we talk about A, B, C, D, and E size sheets, drawing sheets, because we used to plot everything. That's going away. More and more people are using large tablets and tables and large displays to do all this work. But there's still nothing like being out on the job site where they're pouring concrete and looking at your drawing and your copy of the drawing. So these are typical sheets. A is 8.5 by 11. B is 11 by 17. Some places call that tabloid. C is 17 by 22. D and E. Those get pretty big. Architectural sizes are just a little bit different. Okay, because they have a bleed and they want the actual port to be 8.5 by 11. And so they have a little room around it. So their drawing sizes are just a little bit different, but you can see they're still pretty much the same. We use these ANSI ones almost entirely in Design Tech, and you can just sort of see how they go. Okay. So 4 A's fit on a C, 4 B's fit on a D, and 4 C's fit on an E. That's sort of kind of how it's set up. So you should know these things. Go away. 8.5 by 11 we call A size. 11 by 17 we call B size. Now these are becoming more and more like people just have A size, 8.5 by 11. And then we also have, these are what's called portrait. And if we twisted them 90 degrees, they would be landscape. You just have to know how you want to set up your drawing. And that's usually your project leader is doing all that. If you're the project leader and you just got it in your brain and you know it, then it's not a big deal. If you're really coordinating with a large group and you're doing part of it, then it is important, because these sheet sets all go together eventually, whether it be mechanical, whether it be architectural, civil, interior design, whatever. And especially if you're doing graphic design work, you have to know how they want to present this sheet. How is it going to fit on the wall, on the page, on the computer screen? So this is pretty important stuff. Okay, and then there's size. Those are the drawing sheet sizes. And then this is just a little bit about title blocks and those sizes and how they work. So now I'm going to show you, I'm going to go back here, and I'm just going to show you a bunch of title blocks. Where's my... I guess I can just open any of these. There's my title block template drawing. They're not really in. So this is how people often do it, is these are called layouts, and it's a templated layout, and that's a very typical A size landscape sketch drawing. So this is, it doesn't have a lot of information. That's why it's called a sketch. It's got the company name, and it's got, this is like a portfolio page or what it is. It's got a scale, it's got a title, but it doesn't really have much on it. It's just a sketch page. Here it is in portrait. And so that's a typical little title block. Okay. Now, when we get to B-size mechanical, oh my gosh, all of a sudden, this has a ton of stuff. And this is very typical of what goes on a mechanical title block. There's an area for the company, for what is this drawing about? Is it a detail, an assembly, a section, an inspection drawing? What is it of? They got many, many lines here, because sometimes companies say, well, this is the product line, and it's a block, and this is the next description, and this tells whether it's a detail or a fixture drawing or whatever. So this is very typical. This is about sort of the authorization. Who drew it? Who checked it? Who's the designer? Who's the manufacturing engineer? Who approved it? And is it released? Can people actually use it? And then over here, this is sort of like all about the file. Okay, what size drawing is it? How many sheets? What's the drawing number? This is about the revision. That's really important. So those are on most mechanical ones. And then somehow, some way, mechanical ones always tell you about tolerances. There's a standard in mechanical that says you must clearly identify the full acceptance criteria of all dimensions. Well, just imagine if you had to write that on every dimension. So this is where we have a little code. If it's written to 2 decimal places, I'll have a certain tolerance. And if it's 3 decimal places, I'll have another tolerance. So if I write 1.00, I can look down here and go, oh, that means plus or minus 0.03 inches or whatever. Now, there is no standard for what those means. There's just a standard that says we use decimal places to tell us whatever you want. And I've worked at companies where these decimal places were incredibly tight. 2 decimal places were 0.010. 3 decimal places were 0.001. And then after that, we had to get even closer. We had stuff that was in, 10 thousandths, 0.0001 inches. And everything was measured with lasers and stuff like that. There's fractions, angles, and something called surface finish. And then remember on that very first one, it says, well, what is this? Is it inches or millimeters? In a mechanical drawing, somewhere you do have to tell them. And then we didn't really talk about this. This is for later on. What do our projections look like? So that's common. Those are always on there. Many mechanical drawings have what are called standard notes. And they're part of it. And remember that, break all sharp edges. Now, we don't tell them how. They can use a file or a deburr tool or a bead blaster, or it can actually be part of the machining process or a buffing wheel. It just says, we don't want anything, but you can't go overboard. Don't ruin the dimension of that corner by more than 0.03. And do notice they are all capitalized. Here's an interesting one. Well, anybody got an idea about what number 2 means there? What in the world is that all about? And those of you who 3D print will really know about this, right? When you make something in a machine shop, you have to measure it. And if you measure it while it's still clamped to the machine, and then it's okay, and you take it off of the mill or the lathe, it might go boing and spring and twist and warp and change size. So this says take it off of the machine and let it cool off a little bit. Whatever is in the machine shop is fine. But parts get hot when you machine them sometimes, depending on how you do it. So you have to take it off of the machine and let it sit there before you inspect it. Now, some places they go, no, this has to really be close. Take it to the inspection office, put it in there for a day, get it to exactly 68 degrees Fahrenheit at a certain humidity, blah, blah, blah. I have worked in a shop where we had to do that with some parts. And then it's like, oh, and by the way, when you're done, it's probably all gooey and it's got stuff on it from the machine tools and stuff. How do you clean it? So this one says non-detergent hot water spray for 5 minutes. There are some materials where that doesn't work and things like that. So these general notes are usually a block that are just standard, and you just like insert it into your drawing. This is like bank, just put it in there. And you can change them and stuff like that. ATT edit. And you can just change them. The next thing that goes on a mechanical drawing is something that tells you about what this thing is made out of. So that's part of mechanical standards. We're always saying, what's it made out of? And so sometimes there's a formal part of the drawing, and sometimes you just type it in there. And then there's almost always something about the revision. What version of this drawing am I working with? And is this one? So those are typical things in a mechanical title block. And you're going to make a very simple one. We're going to go over it tomorrow that only has a small part of this. And so the purpose of that exercise is just to get you used to how these are made. Every company has their very own way of doing this and how it's done. Okay? So that's that one. Mechanical, and sketch, B size. Okay? Architectural, I'm not sure I have my architectural one open. Let's see. I don't have, oh, here it is. Let me just put that on a new layout so you can see it. It is. It's root mean square. So you take a whole bunch of of measurements, and you take the root mean square. That's what RMS actually stands for. In electrical, of course, that's the root mean square of your sine wave, right? As your of how you're taking your data off of your signal. But it's actually a mathematical concept, and so that's what they do. Yep, yep. And you add up the square of all those values and then take the square root of all that. So that's the getting down and dirty about it. So here's a very typical architectural one, sort of typical. You know what I should do to get a more typical one is open up a Revit. Revit just has super awesome title blocks that have everything that you could ever want to see. They're so standardized. So let's go into Revit to see a standard title block. And you'll see most drawing packages and companies have these. So I'll just make a new. I'll use my architectural template. And I'll do a new sheet. And so this is a very typical architectural template, and you'll see many things are the same. There's something about the scale, something about what drawing number we are. Here's all that stuff that we saw about, who's making sure it's okay and you can use it. Here's that stuff about the company and the project name. Their revision stuff is a little bit different. There's usually a plan that says, okay, this is my massing, this is my overall layout view, this is my 10%, 20%, this is my view for, this is my set for the mechanical to do the bidding on. So there's usually a plan here that's all written out, and it tells you what one you're on and which one this is. Then there's a whole bunch of stuff about who is important. So architectural jobs usually have many, many stakeholders, people that are involved. There's the owner, there's the architect, there's the local architect, there's the mechanical, there's the electrical, there's the if there's a state person on it, that's them. So there's all these consultants that are important and have to sign things off. So they all get listed here so that you can do it. And then there's usually a company logo. You would replace that. You would come in here and you would replace that with your own logo. So that's typical of an architectural, and even civil mostly follows this architectural one. And so this becomes your drawing area, this becomes your title block, and this is a sheet, and this is an E size sheet. Okay, and they have different ones of these. Close that. Nope. And there's many different ones of these we can use. And again, your own company would have your own, but these are typical title blocks. So here's one for, say, a B size drawing. And you can see all that same information is in here. It's just organized as a horizontal or a portrait. Okay, so there we go. That's what I wanted to be able to cover today. Are there any questions about that before we log off? So let me just say, those of you doing landscape and interior design, you will mostly follow what I call architectural. So everything we talked about in architectural, you'll see. And you can imagine on a landscape drawing that that one drawing in the model has everything, and then in your hardscape drawing, you'll freeze everything but your hardscape. And in your irrigation one, you'll freeze everything, but it's all right there, all drawn all on top of each other in the model. Same within an interior design. You'll get the architect's drawing, and then you'll start working with that. And you'll just draw right over the top, and you'll only show the parts that you want. So landscape and interior design follow the architectural because that's who you interface with far more than a mechanical widget goo-ga person. Okay? Any questions or comments before we close off the recording? Okay, then there we go.